Okay, just like when we did this with equations, we needed 0 on one side, right? Everything else on the other. We still need that, right? Because all of this is about whether or not something is positive or negative, and that changes at x equals 0. So for this problem, as a first step, we subtract 12. So now we want to know when is that expression greater than 0? Well, like I said, we depend on these being factorable. So it has to be factorable. If you don't remember, when you have a trinomial, a quadratic trinomial, and this number here is not 1, you've got to go through a longer process. 2 times negative 12 is negative 24. What are the factors of negative 24 that add up to 5? 8 and negative 3, right? I mean, you know it has to be one positive and one negative. And you know that the bigger number is positive because that's positive. So you could think 1 times 24, 2 times 12, 3 times 8, 4 times 6, until you find the one that when you add them up, you get exactly what the middle coefficient is. You remember, what did we do with those two numbers when we found them? Yeah, you had to go like this. 2x squared minus 3x plus 8x minus 12. Remember, you split up the middle term. For this here, you mean like make that the 8 and make that the negative 3? No, you could do either way. You'll get the same answer. The reason that I do it this way is because on the next step, we're going to group, right? Well, let me explain what I'm doing here. When I group like this, right, now whatever that sign is, plus or subtraction for minus, right, if that was a minus, I would have to be careful to flip the sign of the second term by putting a minus in front of the parentheses. So I actually, when I got a positive and negative, I'm always going to make the negative the first one, so that when I do this, I can do the grouping on the next line and not have to write another line to keep this straight. But if you switch it instead, let's say you go okay, but see at this point, if I group these two and these two, at that point I need to remember to do that. Because putting a minus in front of parentheses means that sign changes. And I would prefer not to deal with that. But if you do it that way, you could still be right. Okay? I'll follow through here just because we started it. What's in common between the 2x squared and 8x? 2x times x plus 4 minus 3 times x plus 4. So this is 2x minus 3 times x plus 4. So that's 2x minus 3 times x plus 4. Right, now we need to find the critical numbers. Where do these factors change sign? This one's easy, negative 4. Right. What's the critical number for 2x minus 3? The 0. 3 halves. So if I looked at it like on a number line, which you don't have to, but if you do, that's fine. You know, we know that these factors only change sign at negative 4 and 3 halves. So I'll do it the way the book would do it. I'm just going to test a value in one of these intervals to see what the sign is in between the critical values. And because 0 makes calculations easier, let me test 0. If I put a 0 in here, what is the value of the expression? Negative 12, right? The first two terms are 0, it's negative 12. That tells me that this whole expression is less than 0 in between negative 4 and 3 halves. But we're not done yet. We're just trying to identify the sign on the number line, right? Now, it should change sign on the other side of the critical number, negative 4. So it's greater than 0 here, and it's greater than 0 here. Now, which do we want in this case? Do we want the greater than zeros or the less than zeros? Greater than. So the intervals that we need are -infinity to -4 and 3/2 to infinity. Those are the x values for which this thing is greater than 0.